Welcome back to another installment of the VIPER mainframe emulation system. Today we're going to talk about pointers and addresses. Within COBOL, you can get the pointer to a variable and you can pass that pointer value, so the address value, around to, within itself or to other programs. And if you have the address of that variable, you will be able to manipulate that memory, that memory space. So we go over here and we can see in this program, we have test value, which is going to hold the value, the value that we want. Then we can have a variable type of pointer. And what we see here is, and then apparently I have a variable that's not even used, so forget that for now. What we can do is, we can manipulate our variable with any value, that we want that fits and is the same data type. Then we can say, in any order, it doesn't matter. But what we can do is we can set this pointer type value, so this data type is a pointer, to the address of, so this is an intrinsic function within COBOL that's available on the mainframe, to the address of any variable that we want. So in this case, we'll say, all right, this pointer is going to have the address of whatever this variable is. Now, it doesn't have the length, so you got to be very careful with this. It just has the start address. So you literally could just go for as long as you want. After researching this functionality, because I had seen it in some production code that I'm working with now, it kind of threw me off, this COBOL code. And after doing some research, it's like, this is the Wild West, folks. You have access to memory space from any module. As long as you know where it starts, you can go ahead and manipulate it. To prove that, we're gonna make a call out to 81, passing only the address. Okay, so we're only gonna pass the address. Now, if we look at 81, we're gonna receive the address in the using clause. Remember, this is a list of variables, comma delimited, of what's being passed in. Those are all stored in the linkage section because it's where we link two modules together. This is COBOL syntax. This is not necessarily limited by how the Python's going to work, but we want to emulate, good or good syntax of COBOL code. We want to make sure that we process it correctly, and then the behavior can be emulated using whatever tips and tricks and patterns and practices we can use on a PC with Python. Okay, so anyway, we receive the address value here. Then you can see we use the intrinsic function address of, but in this case, in the context of set, we're going to set the address of this variable to whatever the address was that was passed in. We're going to display that out. So if we go back over here, we expect to see the word test because that's what it was initially loaded with before we made the call. So we can say the expected value is test. We'll see what comes out the other end. Then we're going to update this from the called programs from 81. We're going to validate that update worked. And then we're going to, well, this says stop run. This should be go back. So in a previous video, I discovered this. So I fixed this code in between the two videos. Stop run would stop, literally just stop. So the proper syntax here is go back. So we'll go ahead and make that change live. That's what it's all about. We're making live coding updates. Then okay. So we're going to go back. We're going to make a change. We're going to show that change. Then we're going to go back. We go back to 80, which is the caller, and that change should just be there. But remember, we did not pass it through the arguments. We are manipulating the variable directly because we have the address. So I'm going to go ahead and convert this. We'll run it, and then we'll look at the code behind on the Python. So let's go ahead and do 80. We're going to put that in our converted folder. Then we're going to go ahead, since we know we need it, 81. That goes in converted folder. We'll strike 80. Okay, let's see what happens. All right, so it's initially test. We passed the address successfully, set the address successfully. We have the value test. We made the update from the called program. We can see that that update took effect in the called program. Then we came back, and without making any updates, this variable has now been manipulated with the new data, and that's right here. So it worked. All right, how does all this work together behind the scenes? Let's take a look. So we will keep this open, and then we'll open this one, and we will keep this open. From this side, nothing has changed with the call. You can see we have all our call logic here. We are, passing the value of the address. We're making our call to the main. We're instantiating our 81 class. We're making a call to the main. We're passing in any of the using variables. We're coming back. We're seeing, was it a stop run? No, because we changed it to a go back. So we don't have to terminate here. And, any of the built-in memory space. We're going to get into that in later videos. Then we check and see if anything changed with what we passed. We did not manipulate the pointer, so that's going to remain the same. And then, we do our displays. So nothing here has changed. But we will be coming back to this program because we do have to manipulate the value of test value, right? So let's see how that is done over here. So we go down here, we receive this in, we set the variable address. That's because of this clause, this syntax right here. Set the address of. Okay, great. Let's do that. So we're going to call the helper function to set the variable address. Okay. Once that is set, we have linkage back to the original variable in 80. And I'll show you how that's done in our helper programs. From there, everything remains the same. We are manipulating our data in the same way. Let's see, where is it? You can, right here, the set. So this is where we set it to the new value. That syntax remains the same. In the conversion, because we don't know, later on in the code, over here, all we know is we set this address. Then we just started manipulating that. We don't want to, in COBOL, right, we're not going to be like, oh, is this an address? There's no special syntax for that. It's just, now you have the address, go ahead and manipulate it. So the conversion is going to remain the same. Once we have the address, it's just going to convert to the same syntax for the Python code. Behind the scenes, let's talk about that. So if we go in here, actually, let's go in here. Go to definition. Set the variable address. We have our variable, actually we'll go up here to the top. We have our variable type. Probably a faster way to scroll. Right here, the COBOL variable. So we have this class where we instantiate a new variable object, a new COBOL variable object through the add variable helper function. and that is maintained in a list. So we have our list of data division variables. That's maintained in a list. Then we have our main memory, which is nothing but a long string. I've gone over this in previous videos. And this variable has its, a start and a length so that we know where in the memory space we can go ahead and grab it. So what this is going to do is, I'm not exactly sure what happened here. Okay. Yeah, I accidentally touched the keyboard. All right, let's go back over here. Sorry. We're going to set the variable address. So we're going to find the variable that we're looking for, and then we're going to set its value to the address indicator, which is just, in this case, it's a constant string that I made up, which is 2 ampersands and an asterisk. Why did I do that? Probably because that is a very rare combination of characters that would be used in the real world for human readable processing. Like if we're looking at the code and we're going, oh, it's 2 ampersands and a pointer. Like nobody ever says, I'm going to put code in or put values in there so that another human will be, triggered by it, that it means something, that it's something meaningful. So I just kind of made up some random characters, but I used, kind of the standard nomenclature of ampersands and pointers to show that this is address. So I set the value of this variable, test value, to the address symbol, which basically means I don't care what the position or length is of this. Because what I'm going to do is I'm going to go back and I'm going to look for that from the original. I'm going to look for the value from the original, which is 80, the original module. So if we go back over here, now that we have the address, we want to display it, right? The first thing is let's go ahead and display what that is. So if we go into this helper function, we can look and we can see if we go to get variable. Okay. So then we got to go to this function and we can see if it is an address indicator. So we found our variable that we're looking for in the get. So we're looking for our variable. Okay, we found it. Oh, it's a pointer type. Now I have to go back to my original program. So you can see here, so it's an address indicator. It is not a pointer data type because we are looking for the actual value now. Okay, and that's a picx10, so that's not a pointer. So we go back over here, we can see it is not a pointer data type. So we're going to go back to the original module, and we're going to retrieve that value. Okay. So over here, we have retrieve pointer. So this is the function that has been called, giving me the name of the variable that I want so that I can go get its value and return it back. And then that is the result that is returned to the display function so that we can print it out to the screen. So this is why, again, when we make the call, so I'm going to put all this together. When we make the call, we're passing in the reference to the caller. So in this case, it's going to be self, right? I'm passing myself to whatever I'm calling, which is 81. So 80 is self. It's going to pass to 81. 81 obviously this is Python syntax. It's like I need a reference to myself. Then it says, who is my caller? Okay, that's what this is. We need that reference back so that we can do things like this address resolution, so that we can get and set variables, variable values from any program by passing the pointers around. Okay. So if we look at this again, remember we're going back to the variable, the address module, then whatever that module is. So this is actually a structure. Then whatever that module is, we're going to call the retrieve pointer function using this position, and this position is the name of the variable that we're looking for. In the called program, so this is standard. Every converted Python program is going to have these set of helper functions. Retrieve pointer, okay, fine. What are you looking for? I'll go get it for you and return it back. Then the same with the set. So you can see there's a set here. What are you looking for? What do you want to set? What do you want to set it with? I'll go ahead and do that for you. You're welcome. And I'm going to update my own memory so that when you come and do a get, you can get the new value. Or when you return to me, I will have this updated value because I need it. And in this case, we're gonna display it up here. So that's the basics of how pointers are working. Pointers are available in COBOL. Okay, we need to mimic that functionality. It's done through indicating, okay, this is a pointer. We have that pointer literal, ampersand, star. That's irrelevant. It's just saying I'm a pointer variable. I need the address from my caller. Because we made that call, we have a reference back to the caller. We can reach back to that caller and say, hey, I need information, or I need you to do work for me through the set or through the get. So we have these helper functions. These get created with every converted program. And you can see there's some other ones here: receive control, return code, or get return code, terminate, get DD value. We're going to go over all this later. Process key. These are all things we're going to go over later. But you can see now how everything's starting to work together. We have our memory. We have our list of variables. We're calling other modules. We're setting and getting data. We're passing stuff back and forth through arguments, through pointers, and it's becoming a real robust system here. Real quick shout out kind of to myself. You can see I have lots of examples here. These are all, again, small recipes of code to test very specific functionality. So it's easier to debug, as I'm developing this system out, the VIPER mainframe emulator system, as I'm developing it out, small recipes, unit testing level, sized modules, so that we can, test the conversion of the functionality and then the execution of the functionality. As it stands right now, I have 89 different little recipes. Some of them work together, some of them are independent. You can see number 1 is just your basic hello world, and 89 is, a sophisticated, calling mechanism, between 87, 88, and 89, passing and calling things, and, modules calling modules, and all that. So as we're going along, you can see I do sorts, I'm doing file access, sequential and indexed files. We're doing, different, functionality like ifs and evaluates and data types, comps, comp3, comp5. These are all things I'm going to get into later. But, as I'm discovering functionality that I want to work on, I create a little recipe for it, for myself to make sure that it's converted correctly. But then also we can run these after changes have been made, we can run them, in a unit testing style and make sure that, we didn't break anything along the way. So, all right, given that we're about at the 20-minute mark, thanks for watching. Give me a like, give me a subscribe. Most importantly, give me feedback. Drop a comment in the YouTube channel, or the better feedback is contribute to the repo, contribute to this project. Make a pull request, or do a clone, make some changes, make a pull request. Let's get other people's eyes, ideas, brains involved in this, because I'm one man. I'm doing this, for a purpose. I want to improve developer experience, so that we can develop quicker and not necessarily on a mainframe all the time because of the challenges that has. But it's also now becoming fun. Like this is starting to become fun for me. So let's contribute to that. And until next time, have a great day.